Hello everybody and welcome back to the second tutorial of our vulnerability scanner program. So right now what we did by now, we coded the main function, and right now we are left to code the return banner function and the check once function. So first of all, we will code the return banner function since that is something that we are familiar with. We used it in the previous video, so in the previous program, so let's just make it real fast. The function takes an input of the IP and also of the port. Then we put the two dots and we will run the try and except rule to actually check whether we can connect to that port or not. So we will use the same as before, so socket set default timeout to be around 2 seconds, and after that we want to actually perform the as equals socket.socket, and without actually specifying any other arguments between the brackets. So right after that we want to actually perform the connect function itself, so s.connect to the IP and to the port, so IP, port, and after that we want to receive the banner with the banner equals s.receive 1024 bytes. So after that all we want to do is just press return banner, and in the accept rule we want to just return. So this is the function that we already coded before. There is not too much to explain, it is same as before, so let us continue with our check vulnerabilities function. So def check once, which takes an input of banner and file name, so let me just check it right here, so banner and file name. Right after that, we will use something that we didn't use before, which is actually managing files in Python. In order to open a file in Python, you basically need a variable, which will be the file descriptor, and you need to just type open. In the brackets, you need to specify the file name, which in our case, it is just a variable file name. And after that, you need to specify the mode in which you want to open the file in. Now, there are 3 available modes. One of them is read, the other one is write, and the third one is append. So you can specify all of those 3 with a simple one letter, which is W for write, R for read, and A for the append. In our case, we only want to read from the file, since we want to read and compare the contents of the file with the contents of banner that we received from the scan. So we will just specify double quotes open and close, and then between them the R for read. Then you close the brackets, and that is how you open a file in Python. Now we want to actually read from that file, but we want to read line by line, since we specified the vulnerability.txt file to actually have vulnerable software that are separated by each line. So let me just show you. If I just save this in a second, and here I have vulnerabilities.txt. If I nano the vulnerabilities.txt, here I have some gibberish. And in a third line, I have the actual software that is running on Metasploitable 2 on port 22, so the SSH port. And we will then compare each line with the banner that we received from the open ports. And if they are equal, or basically if we find this to be in some kind of a banner, we will print that the software is actually vulnerable, and we will print it to the screen. So let us close this and nano back to our polscan.py. And now we want to use a loop which will basically say for line in file.readLines, open and close brackets. This is a function that we use to read line by line, and we will store each line in a variable that we named just line simply. We want to actually compare right now, so if line, and we want to strip out the new line characters, which is \n, and then between the double quotes, is in banner. So if this line.strip, the new line, is in banner, we want to print server. So we will just type it right here. Server is vulnerable. Is vulnerable. And then we want to print the actual vulnerable banner. So banner.strip and then we will strip the new line so it doesn't present any problem to us. And basically this should be the entire program. All we have to do right now is actually run the program on our targets and see if it will be able to find the SSH port as a vulnerable software running on our Metasploitable tool. So let us save this, Ctrl-O to save, enter, Ctrl-X to exit. We have our vulnerabilities.txt file containing the vulnerable banners. We have the vulscan.py, which is our program. Now let's actually try to run it. And it gives us the usage. Since we specified it wrongly, we need to specify the name of the file with the command. So we will specify it like this, vulscan.py, and then vulbanners.txt. So right now, if I press here enter, it will perform the scanning of the localhost machines from 4 to 6, from the IP address ending with 4 to 6, and then hopefully it will find the Metasploitable SSH port as a vulnerable software running there. And as we can see, it has finished. It found the open ports, it found the versions of software running on those open ports, and it also found that the server is vulnerable with this software running. It scanned the Metasploitable on port 22, found the banner, and right after that it printed out that the server is vulnerable because this banner right here is also contained in this vulnerabilities file.txt. So of course with the real scans you won't really be using a file like this. What you want to do is actually download from the internet a file that contains vulnerable software names, and then you can compare it like that with your scan. So that would be about it for this section. In this scanning section we coded our simple port scanners, and then later on we coded the advanced port scanners. We also finished off with the program that returns the banner of those softwares running, and we finished off our scanning section with the vulnerability scanner on open ports. So hope you enjoyed this section, and hope I see you in the next lecture where we will continue coding. Have a nice day and take care. Bye. Hello everybody, and welcome to the scanning section where we will code the tools that we will use to scan our target. Now before we actually start coding, let's see what scanning really means. So in Kali Linux there comes a tool which is actually called Nmap. It allows us to scan the targets for the open ports which could potentially run vulnerable softwares on them, which we can actually possibly exploit afterwards. So this is the first part of actually collecting some information about the target. We want to scan for its open ports, and we also want to see what kind of version of software are they running on those open ports. After that, once we find that out, we actually want to, for example, see if that version of software is vulnerable to some attack or not. Now, in order to do that simply in Python, in Kali Linux, you just type here nmap and then the IP address or the host name of the target. So if you just type here nmap and then let's say we use the IP address of my laptop, which is 192.168.1.15, which I checked out right now. And if I just try to scan it, which I can do it with this command, it will just scan my laptop for the open ports. And as we can see, it finished relatively fast. And it found an open port, which is port 80, which services the HTTP. So let's try to actually code something similar to this, which will allow us to actually scan a target that we specify and which will actually check if that target has an open or closed port. So let's see how we can actually do that. So let's just clear the screen with the clear command. And let's in our Python programs, first of all, let's delete the test.py from the previous video. We do not need it anymore. You can delete it with the rm command, which you should be already familiar with. And right now, let's create an actual directory where we will only save the files for our scanning. So let's call the directory scanning. Make sure to make it in the Python programs directory. So I will mkdir scanning, which is also a command you should be familiar with. And if I just type here ls, we have our scanning directory. So let me change my directory to scanning. And let's actually write the program and call it, for example, portscan1.py. So since we will code multiple ones, we will try to actually make them better and better as we go. So let us actually just type here portscan 1.py. And let's try to write a simple port scanner, which will just scan a simple port. So how can we do that? Well, first of all, as I said in the previous videos, what you need to do, in every Python program you run in Kali Linux, it must start with a line, which is this. So hash, exclamation mark, /user/bin, and then /python. Now, why is that? If you skipped through those introductory videos, basically this just specifies the path to the Python libraries that we will use. So this is something that you must have in your program. And after that, what we want to do is we actually want to import a library which will allow us to perform the connect function on target ports. Now, performing that connect function will actually allow us to see if that port is closed or opened. If we manage to connect to that port, that means the port is open. If we get connection refused, for example, that means that the port is closed. So we will use the library called socket. So we will just specify here socket. You specify the library to import with the import function right here. So import socket will give us access to all of the functions that are in this library called socket. And right now, what we want to do is actually create a socket object and then basically perform the function which will actually connect to the port itself. So in order to create the socket object, it can be a little bit tricky syntax, so make sure to follow with me. You can call it anything you want. I will call it sock in my case. So sock equals, this sock basically represents a variable, so we can just put anything to that variable with this equal sign. And we want to make it a socket object, so how do we do that? We just type here socket.socket, open brackets, so open and close them, and inside the brackets you want to type socket.af_inet, comma, socket.sock_stream. So this is how we actually define the socket object itself, and we actually put it as a value to this variable right here, which we called sock. Now, this socket.af_inet basically stands for the IPv4 address, so we will be performing the connection to the IPv4 host, which is the IP4 and not IPv6 address, and this socket.sock_stream represents that we are going to use the TCP packets in order to perform the connection. Now, TCP and UDP, we want to perform the TCP three-way handshake and not UDP packet. Well, basically, for those of you knowing, UDP is actually connectionless, but it really doesn't matter at this point. Right now, it matters that you know that this stands for the TCP packets. So we will be trying to perform the three-way handshake with each port of the host, but for now on, let's just actually try to perform it with only one port, and then we will see how we can actually scan multiple ports and not just one. So right now, what we want to do is actually just type here the value host, which we can set to be, for example, my laptop, which is 192.168.1.15. Now, make sure that you actually, don't worry, I will show you how you can install the virtual machine where you can actually perform all of these scans and all of these attacks that we will do. But for now on, you can just select any IP address you want, such as the IP address of your Kali Linux machine itself, so you can actually scan yourself, or the IP address of your actual main PC or Windows machine, in case you're running Windows. Now, how can you check the IP address on Windows machine? You just go to the tab right here, type here cmd, and then in your command prompt, once it opens up, you can just type your ipconfig, and the result of the ipconfig will actually give you your IP4 address, which is the local address, which in my case is this one right here. So make sure to navigate to the IPv4 address and select the address right here, which is in my case 192.168.1.4, which is the IP address of my Windows 10 machine. So we can scan my Windows 10 machine. Let's just type it right here, 192.168.1.4. We close the quotes since we specified the host. We also want to actually specify the port, so let's specify the port to be, for example, port 443. And we will try to perform the connect function to this port on this host. Now this is the most simple port scanner. Don't worry, we will make the more advanced port scanners later on, but for now on I'm just showing you the basic principle behind actually scanning and connecting to a certain port. So let's try to actually connect. So in order to do that, we actually need to make a function. So in order to specify the function, you just type here def and then port scanner. And in the port scanner, what we want to do is in the brackets, type here port. Now, let me just explain this. In order to declare a function in Python, you need to use this def before it. Then the port scanner is the name of the function that we want to create, and the port is the argument that we will pass to the function. Now, after that, all you need to do is specify two dots, which basically means that the code below and the code that we will basically tab in will be the part of the function itself. So, how do we do that? Just press here enter, tab this, and we can just type here something like this. If sock.connect underscore ex, and then in the ex you specify two open or double open brackets and double close brackets, and inside them you specify host and then comma port. Let me just write this and then I will explain what this means. So first of all, I will write the code of the function and then I will tell you what all of this means. Don't worry, I will explain it all. So print port and then %d is closed and then %port. Oops. And then we just type here else. Oops. Print port %e is opened. And then port. And then at the end we want to call the function itself. Okay, so this is basically our most simple port scanner. Let me just explain what I did right here. So let's start from the beginning actually. So we created the socket object. This is the stands for IPv4 and this stands for TCP packets. We declared the host variable to contain the IP address of our Windows 10 machine, and we selected the port to be, for example, 443. You can select here any port in order to try it. Don't worry, it doesn't have to be 443, or you can go with the 443 like I did. Then we declared a function which will perform this task right here each time it is called. Now the function is named port scanner and it will take one argument which will be called port. So after that we need to close it with two dots and then we need to tab every code that we want to be a part of the function. So for example, if I were to type here any code, this will not be a part of the function anymore since it is at the same line as the function itself. But if I were to do this, now it would be the code of the function since it belongs and it is tabbed properly. Let me just delete this as this is not really a code. And right now, what we do in the function itself, we perform the simple if-else statement. Now, you can look at the if-else statement as something like, basically, you can basically translate it to English. So if this doesn't work, or if this works, then do this, else do this. So if socket.connect retrieves an error, any type of error, which we actually check with this function right here, so sock.connect underscore ex, we try to connect to the host on this port, so on this host and on this port, which we specified in the double brackets separated by comma. If it retrieves an error, that means that the port is closed since we got the error back. So we will print to the terminal port is closed. Now this %d basically stands for anything that you specify after the string itself, it will be replaced right here. So since our port is actually number 443, if this port is closed, this will print port 443 is closed. else, so in any other case, so if we don't get an error, that means we successfully connected to the target, and that means that port is actually opened. So in that case, we will print port and then the port number is opened. So let us save this and see if this will work. Now before we save it, this part right here is basically how you can call a function. So if I didn't have this part right here, this function will never be called and this program will not execute this at all. So we need to call the function and we specify the variable inside the function, which is our port variable, which will be used throughout this program. So let us save this, Ctrl O to save, enter, Ctrl X to exit. And as you remember, in order to run this, we need to make it an executable first with the chmod plus X. Then we type the name of the file itself, so chmod plus X portscan1.py, and let's actually try to run it. You let it run, and we can see port 443 is closed. So right now, let us actually try to scan our Windows 10 machine with nmap to see if there is any port that is actually opened, so we can actually use that port in order to check if our program will print that port and then that number is opened. So let's type right here. This should finish relatively fast, and we can see these are the open ports on my Windows 10 machine. So port 445 is open, port 139 is open, and port 135 is open. So let's actually change our program. So nano portscan1.py. We open the code itself and we change this to 445, since 445 is one of the ports that was open. We Ctrl O enter, we then exit this and we run the program once again with the dot and then slash portscan1.py. And we can see right now it prints port 445 is opened. So now we know that our program works correctly. It can actually scan port if the port is open or closed. But this is the most simple version of our port scanner, so we will actually in the next few videos try to make it better, implement some different functions, make it scan more ports than just one, and so on and so on. So hope you enjoyed this introductory video to the port scans. Now for those of you who are actually a little bit more advanced and know Python and know all of that, it might be a little bit too much explaining for your taste, but please stick around. Later on we will be coding some of the more advanced stuff, don't worry. And later on, the more we go with these programs, the less I will explain what I'm doing in them. So that would be about it for this tutorial. Hope you enjoyed it, and I hope I see you in the next one where we will actually try to change some of the stuff in our port scan. So hope I see you there and take care. Bye. Hello everybody and welcome back, and let us continue with our port scanner. So let me just log into my Kali Linux machine, and in the previous video we coded the most simple version of a port scanner. We provided the IP address and the port that we want to scan in the code itself, and we were able to actually determine whether that port is closed or open by performing the socket.connect function on that local host and on that local port. So let us see how that program looked like, so we can actually modify it. Now let me zoom this in so you can see this a little bit better. Let me just get this. So view, zoom in. I will zoom in twice so you can see everything really well. And if I just type here ls and go to my Python programs directory with this cd command, if I ls once again, I have the scanning directory, so I will go to the scanning directory as well. And here is my portscan1.py. So let us actually nano that portscan1.py in order to see what we can actually change in order to make this a little bit better. So let's think about this. First of all, there is really no point in actually making the user of our program actually specify the IP address and the port in the program code itself. Maybe some of the users don't really know how to actually open the program and how to specify and where to specify the local host. So what we want to do is we actually want to prompt them with the question to specify the IP address themselves and the port as well. So let us see how we can do that. Basically what we want to do is we want to delete these two values, so delete the IP address and delete the port. And instead of that, what we want to do is we want to actually prompt the user of our program to specify any IP address they want and any port they want. So let us see how we can do that. So we can do that with the raw input command. As we can see, raw_input will prompt the user with the question that we specify in the brackets. So you need to open and close brackets, and between the brackets open the double quotes as if you're specifying the string, and there we can just prompt the user something like this. So plus, or let's just type here star, doesn't even matter, this is just some decoration, and just type here enter the host to scan, then 2 dots and then space. So this means basically the raw_input function means that this will be prompted once the user runs the program, and it will wait for the user to specify the IP address or basically anything they want to specify. In our case, in this program, it will be an IP address, and so as they specify that, it will continue running the code, and it will go to the port where we want to do the same. So raw input, we want to prompt the user to actually specify the port which they want to scan. So we just type here enter the port to scan, 2 dots and then closed question marks, closed double quotes and then closed brackets. So as we can see right here, right now if we actually run this, so Control O to save this, enter and then Control X to exit, and we run the port scan1.py, you can see that right now it asks us enter the host to scan, and it waits right here until we actually write something. So let us check the IP address of our Windows machine once again, since I restarted my computer since last video, and okay, so it's still .1.4, and if I specify 192.168.1.4 and I press enter, it will ask enter the port to scan. Now if I just specify here the port number, this will most likely crash. So let me just show you. If I specify 445, which is an open port on my Windows 10 machine, as you can see, it crashed. Now in Python 2, it will say an integer is required. So all you have to do is nano that port scan1.py and just type here raw input and then integer. So open brackets, integer, open another brackets, leave this as we specified, and at the end just close double brackets. Now what this will do is basically the value that the user specifies, it will turn that into the integer which is needed in order to perform the port scanner function. So let us save this once again and exit. And if I run this once again, so I specify the same IP address, 192.168.1.4. Oops, enter the port to scan. Okay, so let me just check this out. We probably need to specify it like this. So delete this integer and type before the raw input. Yeah, I believe this is what we need to do. So it first goes integer, then open brackets, then raw_input, then open brackets, and then this string right here, and then 2 closed brackets. So let's save this once again and try to run it. 192.168.1.4 and then port to scan 445. As we can see, then we get prompted port 445 is opened. So right now, first of all, we should not specify is opened, we should specify is open. I believe that is the correct English. Pardon me if I am wrong, but it doesn't really matter. So port is open. We can now specify any IP address. So let's see if we can actually run the program twice. So let me just clear my screen. We run the program with this command. We scan once again my Windows 10 machine on port 139, for example. Now port 139 is open, which is correct. And then let's actually try to scan my router, which is at the IP address of 192.168.1.1, and I scan the same port. And right now, as you can see, this will hang. Now don't worry, this is actually hanging because my router is really slow. So in order to prevent from this hanging on certain hosts, we can add a simple one line code to our port scanner in order to prevent this. So let me just control Y this in order to close the program itself. Let me nano the port scan 1.py, and all we have to do is right here specify socket dot set default timeout, and then default timeout will be in the brackets in seconds. So let's specify 2 seconds. What this will do is it will actually try to perform every action within the 2 seconds, and if basically the 2 seconds expire, it will just print the port is closed. So let's see if this will work. Control O to save, run this once again, set default. Okay, so this is a typo. Whoops. It's not set default. We need E right here. So set default timeout. Save this and run the program. 192.168.1.1, 139. And we wait now 2 seconds. And that is more than 2 seconds, but I'm not really sure why does it take so long. But I always had this problem with my router. It doesn't really matter currently. What matters is if I run this on my laptop, which is .1.15, so that is the IP address of my laptop, and I specify port 80, we get everything within matter of seconds. So port 80 is open. Let's try now other port on my, for example, Windows 10 machine. Let's try port 33. Now this will actually scan and it will say port 33 is closed. So we did a little upgrade to our program. As you remember in previous video, we actually specified both the IP address and the port in the code itself, and right now we prompted the user to specify any IP address and any port they want. So let me just nano the program itself. So as we can see, we changed this part and we also added this socket.setDefaultTimeout to be 2 seconds. So in the next video, we will actually upgrade even more this port scanner and we will try to make it scan multiple ports and not just one port. So I hope you enjoyed this video and I hope I will see you in the next one. Bye! Hello everybody and welcome back, and in this tutorial let us actually make our port scanner to be able to scan multiple ports. So let us nano our portscan2.py. In order to do that, we will actually need to remove this line, so you can either put it in a hash, so it actually counts as a comment, or you can delete the entire line since we don't really need it. We don't want to prompt the users for the port, since we will be scanning multiple ports. And if you want to, you can actually scan all 65,000 ports. But for now on, we will just want to scan first 100 ports, and we can do that with adding right here. First of all, let's delete the calling of a function and let's add a for loop. So for port, in range from 1 to 100, we want to call the function on that port. So what this will do is basically, first of all, the port variable will be 1, and for port 1, this will call a function port scanner for the number 1, which will scan the first port and it will determine whether the port is open or closed. Then the port variable will increase by 1 and then it will scan the port number 2 and so on until it reaches 100 ports. So you can specify more ports right here, but for now on, let us just try to scan first 100 ports. I will be scanning my laptop, so let us run this. The IP address of my laptop is 192.168.1.15. I let this run and we can see it finishes relatively fast, and the only port that is open on my laptop is the port 80. As we can see, port 80 is open, but let us actually try to scan first 1000 ports right now. So in order to do that, all you have to do is just specify right here another 0, and it will scan first 1000 ports instead of first 100 ports. So you specify the same IP address or the IP address of any host machine you are actually scanning, and we can see it finishes the first 1000 ports as fast as the first 100 ports. But you might notice right here that it is actually really hard to notice whether the port is closed or open, since all the letters are white. And here is the port 80, which is open. So let us actually try to code something that will make this the ports that are closed print in red and the ports that are open print in green. So we can do that with the help of a term color library, which actually comes in Python 3. So we'll have to adjust our code to Python 3. All we have to do is just fix the print statements first. So in Python 3, the print statements need to have the brackets. So let us add brackets at the beginning and the end of our print statements. So just add it right here. And also in Python 3, the raw input function is actually just input. It doesn't have the raw and the underscore before that. So right now, in order to actually color the print statements, we need to import the library. So for term color, import colored, and we need to call the colored function in our print statements, which we can do right here. So colored, open the brackets, then after the port specify comma, and then there we want to print the closed ports in red, and then add one bracket at the end. You need to do the same in the port is open statement. So here, add function colored, open brackets, then comma after the port, and we want to print that in green, as it is an open port. So all we have to do right now is save this and run this with Python 3. In order to run it with Python 3, we specify Python 3 before, and just type here port scan2.py. We run this, enter the host to scan 192.168.1.15, and as you can see, all the closed ports are printed out in red, and the open port, which is port 80, if we find it, should be printed out in green. And as we can see, it is printed out in green, and it is really easy to notice it. So our port scanner works well. It can scan multiple ports, and it can also print out the open and closed ports in different colors. So that will be about it for this video. I hope I see you in the next one, where we will actually start coding our advanced port scanner. Hope I see you there, and take care. Bye. Hello everybody, and welcome to the first tutorial of actually coding the more advanced port scanner. Now we will code this port scanner in the Python 2. Basically we will use Python 2 to code it, so let us see how that will work. Let us actually first ls, and let us nano advanced scanner.py. You can call it anything you want. It doesn't really have to be the advanced scanner itself, but I just named it like that because it will be easy to differentiate it from the other scanners. So right now we need to start with the regular line, which is user bin Python, and we need to import 3 different libraries for this program. Now why am I calling it advanced? Well, I'm calling it advanced since it will have a better help option, or I don't know how to say it. You can specify the help option with the program itself, and it will prompt the users how they can use the program, which will be really easy to use for anyone running it. They can also specify the ports, the number of ports, the host, and also we will run the program with a threading library, which allows us to scan the ports faster than without the threading library. So we will use different threads in order to scan different ports, which then will actually simultaneously scan the ports and get prompted us back with whether that port is closed or open. So the 3 libraries that we need to actually import are the socket library. So we will use from socket import star. Now this basically means that from the socket library we want to import everything. This star right here basically represents everything. The next library we want to import is the opt parse library, so import opt parse. This library allows us to actually specify the help options that we will get prompted to the user, such as actually specifying the ports and specifying the hosts, and if they specify, for example, -h, which will stand for -help, they will get the usage of the program printed out. And the third library is the library that I mentioned, which is the threading library. So from threading, we want to import everything. Now, you might be asking, why are we not just importing, for example, socket library like this? Well, basically, since we are going to use this a lot, I believe, we will just specify from socket import everything, so that we don't have to specify the socket prefix in every function we use for the program. So make sure to specify it the same as I did, since some functions, if you just specify it as an import socket and import threading, will not really work. So let's see what we actually need to do in order to get this program to work. What we will have is, we will actually have a main function, so let's call it main, which will take no arguments, of course. And here we will actually code the available options for the user. If the options are well specified by the user, then we will continue to actually scanning the target and printing whether the port is open or closed. So let's see how we can do that. We can do that with simply using a variable which we can actually call parser, which will then equal to the function we will use from the opt parse library. So that function will be opt parse and then dot. The name of the function is option parser. And then between the brackets in option parser, that is open and close the brackets, we want to specify, for example, the usage of the program itself. So we can just do that by specifying them between the double quotes. And here we will actually type here usage of program, so of program, and then 2 dots, space, and then here we want to specify what they need to specify in order to actually run this program. So plus, we want to plus this. Now this plus basically means it will add a string to another string, so we need to specify that plus and then open another quotes, so open and close the quotes, and minus h, capital H, or you can use lower letter h, it doesn't really matter. And then we want to specify target host, and then minus p, or let's actually use the h to be smaller, or bigger h will be the target host and smaller h will be the help option. Or we will even see, it doesn't really matter. Let's use minus p for the ports, and here we will specify target ports. So this is the simple usage of program that will get printed out once the user actually specifies the command wrong or doesn't really know how the program works, so they will get printed out this part right here, and after that they will know what they need to do in order to run this program correctly. So right now what we need to do, since we specified the minus h to be target host, which is the IP address of the host they want to scan, target, not target, and minus p to be target ports or port, so let's just leave it on port so that then they don't get confused. And right now, what we want to actually do is add both of those options to our parser. We use the add option function to do that. So parser dot add underscore option. And then we need to open and close the brackets. And what we want to do is specify some of the settings for our minus h option, which in our case is target host. So between the double quotes, specify minus and then capital H, if you specify capital H right here. And then after that, comma, and then, comma, and then you need to specify destination to be to our variable, which will actually take the input from the target host. So we can call that variable whatever we want. So let's call it tgt host, which stands for target host. Now this actually needs to go between the quotes. So let's specify the quotes right here. tgt host, then specify after that comma, and then the type of that variable is string, so type equals, and then we need to specify between the single quotes string, which stands for that variable actually being a string itself. And the help, which will be something that the user will actually get prompted, will be, for example, for this option, again between the double quotes, or the single quotes, pardon me, specify, or let's do it like this, specify target host. So this is just parsing the first option, which is minus h. Let's do the same for the second option, and we can do that just by copying this line right here. So copy and we will paste it right here, so we don't actually write it, and we will change what we need to change. So the parser.add option is the same, and now we want to actually parse the option -p, which is the target port. The variable cannot be the same, so let's name the variable to be target port. The type of the variable will still remain the string, and the help will be specified target ports separated by comma. Now, why are we using target port separated by comma? Well, we will add a function to the user, or basically an option to the user to specify multiple ports that they will specify, or that they will actually separate by the comma itself. Now, all we have to do is to actually first parse the arguments to the variable, so options, comma args, and then we need to use the parser, which is our variable right here, and we need to parse those arguments. Now, basically, if you are new to this, this can be a little bit difficult syntax, but it doesn't really matter. This is just the syntax of the Python library itself. It is not really something to worry about. Basically, in this ops parse library, there are the functions such as add option, parse args, that are used to actually specify different settings for this program. This is really optional thing. We just want to make it the best we can. This really isn't really needed for the port scanner itself, as we saw in the previous videos where we actually managed to scan the ports, whether they are open or closed, without using this. But if we want to, for example, put this program on GitHub, we want to actually make it a little bit prettier and a little bit more user-friendly. So all we have to do right now is actually specify our variables. So we used two variables, the target host and the target port, and right now we need to set them to be target host equals options.target host. Since we only specified them in these two lines, we didn't really specify them as a variable itself. So right now we need to make sure that the target host is referring to the options.target host, which is this right here. We need to do the same for the ports. So we will use now the variable called tgt ports. In this variable, we will actually use the ports that the user specified that are separated by comma, so we need to actually see how we can actually separate them. We can do that simply with this. So first of all, equal sign, then the ports need to be string, and then from the options, we will use the variable tgt port, and we need to split them, so split each port with the comma. We will use the split function to do that. So what this will do, if for example we specified something like this, so 1, 2, 3, 4, we want to scan first 4 ports. What this will do is it will add all of these ports to the target ports, but it will separate them from the comma. Since if you try to scan a port with a comma, it will not work and it will prompt us with an error. This function split allows us to actually split them by the comma itself. So all we have to do right now is actually check if the user specified correct arguments for the program, and then we can actually proceed to the scanning of the ports. Now we can do that like this. So if target host equals to none, which basically means if they didn't specify anything to be a host, and if target, or basically and or if target ports, since our variable right here is called ports, which is a list, basically holds on to the 0 variables or 0 ports, that means that our program has nothing to scan, or basically equals to none. We want to actually print the usage of our program, which is this right here. So usage of program, we want to print parser.usage. Once we print that, we want to actually exit the program. You can exit the program with this command right here. And in case that everything is good, so in case this isn't satisfied, we want to proceed to the function which we will actually call port scan, which will take 2 arguments and which we will code in the actual next lecture, not really now. It will take 2 arguments, which is target host and target ports. And this is basically the usage of our options right here. So let me just see if we actually run the main. So let's run it. And let's put this under the hashtag as a comment, since we don't really have the port scan function yet. So let us just save this, Ctrl-O to save, and let us try to actually run this. We need to make it an executable with chmod plus x function, and then we actually run the advanced scanner. And we get printed the usage of program, since we didn't specify -h for the host and -p for the port. So our help option works well. Now in the next lecture, we will try coding the port scan function, which will actually perform the threading on actual scanning the ports themselves, and then we will see how that will work. So hope you enjoyed this video, and I hope I see you in the next one. Bye! Hello everybody and welcome back, and right now let us continue with coding our advanced scanner. So let me just nano the program itself, and in the previous video, as we saw, we managed to actually create the help options for our user. Right now let us create the port scan function, which we specified as the last line of our main function. So let us actually unhash this, and let us use a simple usage of actually running the main function, which is common in Python, which goes like this: if name equals to __main __, then run the main function. So let us now code the port scan function itself. As we saw right here, the port scan function takes two arguments, which is the host and the port. So let us code it right here. Def port scan. Make sure to name it the same as you named it in the main function, otherwise this will not work. And then we need to specify the two arguments, which we specify right here, which will be the host and the port or ports. We need to end it with the two dots, and everything that is tapped into under this function will be the part of the code. So first of all, what we want to actually do is, what if the user specifies a domain name instead of the IP? We want to actually resolve that domain name and actually get the IP address of that target. So for example, if a user typed -h for the host, and then after the -h typed google.com. If our program didn't resolve that google.com into an IP address, this program will crash, and it basically won't be able to scan, since it doesn't really know what google.com is. So what we will do is we will use a function called getHostByName in order to do that. But sometimes it might actually crash, so let's use a try and except rule, which will try one thing, which will be the resolving of name, and in case it can't resolve the name under the except thing, we will actually specify to print out can't resolve the name of the host. So let's see what we actually first need to do in order to resolve the name, so, or the IP address from the name. So actually what we need to do is actually make a variable which we'll call target IP, and that target IP will host the IP address of the host. So we need to get host by name, which is the function we use, and from that we will specify in that function the target host, since that is the host that we need to get the IP from. So this is the entire function that we need to specify for this, and in the except we will just print can't resolve target host or something like that, or let's just print unknown host, and we can print something like this. Oops, the %, and then s, and then we can close this and then type %, and then target host. What this will print is basically, if you remember with the %t command, this is the same thing, just this is referring to a string. Now first thing, we need to make this a single quote, so this will actually work. So let's recap what this will do. It will try to get host by name, or basically get the IP address, and if that doesn't work, it will print unknown host, and then it will print the host name. So right after that, we actually want to print that it is trying to scan the host itself. So let us just run the another try and except rule right after this first one. So we ran the first try and accept rule in order to get the host by name. And right now we want to actually get the name, so we can print it out. So target name equals get host by address, and then from target IP. Now, as we can see, these are similar functions, but they do the opposite one from another. This one gets the host name, or basically the IP address from the host name, and this one gets the name from the address. So right now, once we actually type that, we want to actually print, and let's add a plus right here, and let's actually print scan results for, and then we can just do it like this, and then add the target IP. What this will do is it will basically print out scan results for that IP address. Or no, we want to actually do this in the accept rule, so pardon me, this is not a part that goes right here, so let me just delete this. This is the part that goes right here, so paste this under the accept, and in the try we actually want to print the target name. So print, and we want to type it right here with a plus, so it knows everything works well. Scan results for, and then we can add the target name. And since target name, we can actually try, since target name retrieves as a list, we need to use the first element of that list, which we will specify with this 0 in the square brackets. Now, if you're not familiar with the lists, or basically the counting in Python, the counting always starts from 0 and not 1. So the first element in the target name list will be marked with the number 0 and not with the number 1. So now that we did that, we can actually use the function that we used in the previous video, which is set default timeout, so we don't actually wait for an eternity for a single port to scan. So set default timeout to be, for example, 1 second. And right now we can perform a similar function, or a similar part of code that we performed in our previous program. So for target port, so for target port, in target ports, which basically means for every port in all of the ports that you specified in the command, we want to actually run a different function which will scan those ports. And we want to run all of those ports with a different thread. So how can we do that? We will use a variable called th to select a thread, and we will use thread, open brackets, close brackets, and right here what we want to do is type here target equals, and after this target equals we need to specify the name of the function which will perform the scanning of the ports. So we will call that function, for example, connection scan, so con scan, then comma, arguments for that function will be actually just the target host and the target port, so make sure to separate by comma, then args equal open brackets and close brackets, and in those open and close brackets we specify target host, and we specify the integer of the target port. We close the brackets for this, so make sure you have 3 brackets at the end. Since we opened 1, 2, and 3 brackets, we need to close all of those 3 brackets. Now basically, you might be asking, why are we using integer? Well, we use integer for the same reason that we used it in the previous video, or pardon me, in the previous program, which is the port scanner 2.py, I believe, since the socket library actually needs an integer value of port in order to be able to scan it. And all we have to do right now is actually start all these ports. So in order to start the port, you just use this variable and added a function called start. Simple as that. And all we have to do right now, which we will do in the next video, is actually code a simple connect and connect function which will determine whether the port is closed or open. So that's an easiest part, so don't worry, we already performed most of those things the same, and we will finish the program in the next tutorial. So hope I see you there, and take care. Bye. Hello everybody, and welcome back to the last part of our advanced port scanner. Right now, we managed to actually make a function called port scan, which will actually try to resolve the IP address by hostname and hostname by IP address. Then for each port in the specified ports in our command right here, we will actually run a function called connection scan, which will actually determine whether that port is closed or open. We set that on all of the separate threads, and we also set the default timeout to be 1 second. We call that function down here, as we can see, port scan target host target ports. Then once it goes right here, it will start executing all of this code. Then it will run all of the different threads on connection scan function, which we still remain to code. So let us go up here, make def, or let me just def conscan. Once again, make sure that you specify the same name for the function as here. So conscan, and we need to specify the arguments, which will be target host and target port. Now right here, we do not need to specify the integer, so all we have to do is specify the 2 dots at the end. And right now, we will actually try to perform the same thing that we actually did in the previous programs, which is just trying to connect. So let's run the try and except rule. In the try rule, we will actually try to make a socket. So let's make a sock object, which will actually we need to actually make it to be, first of all, the IPv4, so AF_INET, and then sock stream for the TCP. Now, in the previous programs, you remember that this was like this, so socket.af9net and socket.sockstream, as well as this was socket.socket. Well, it is not in this case because, as I said in the previous videos, we imported it like this, so we do not need to specify the first socket part in all of those functions. So it is easier to just write one socket and not twice socket. So let me delete all of this, since we don't need it, since we imported the library as from socket import everything. And basically, we will now try to connect to those ports. So we can just perform sock.connect, or open 2 brackets, close 2 brackets, and between we need to specify the target host and we need to specify the target port. So this is all we actually need to do in order to perform the trying of the connection. All we have to do right now is also print whether that port is closed or open. So print, if it manages to connect, we will print, let's print it like this, so %d for the integer, then slash, and we will just type it right here, so TCP, so we know that the port is scanned with TCP, open. Let's add the capital O, maybe it looks better. I don't even know, you can write anything you want right here, and we need to specify the percentage and then target port, so we know which variable we need to specify instead of the %d. And let's add space right here. And in the except rule, all we have to do is actually print %d TCP closed. And close the quotes and then add the percentage and then target port. And finally, we need to print connection.closed or sock.close. We want to close the connection so our program can close successfully, so sock.close. And this is our entire program. So if we coded everything correctly, which I believe we did, this right now should actually be able to scan our Windows 10 machine or basically any other website that you want to scan. So let us Control O this. We just double check if we coded everything properly. Everything should be good to go. So Control X to exit. And right now, if I just type here advanced scanner, you can see that we actually have, oh, I'm missing the double equal down here. So right here, make sure to specify double equal always, since one equal actually means that you're adding the value to a variable, and double equals basically checks whether these two are actually equal. So let's Control O, then Control X, and we get printed out the usage of our program. So right now, let's try to specify the usage of our program, which we will use 192.168 -H for the host, which we will use 192.168.1.5 4 for my Windows 10 PC. And -p, let's actually first of all scan one port, which will be 135. If I just run this, we can see scan results for 192.168.1.4, 135 TCP open. Now let's actually try to scan multiple ports with the different, with separated by comma. So 135, 22, 443, 445. Let's try to scan this. As we can see, it finished. It found two open ports, so 135 TCP open, 445 TCP open, and 22 and 443 are closed ports. So as we can see, it finished relatively fast, and it also prints out in the nice manner whether the port is closed or open. Now if you want to, so let me just, you can actually make the same thing as in the previous video, whether the print statements will be printed out in red or green, whether the port is closed or open, but I will not be doing that right now since I already showed you how to do it. Just make sure that you need to run it afterwards with Python 3, since the term caller library that we used in the previous videos is actually only in Python 3. And the print statement is different in Python 3, everything else I believe will stay the same, but if you want to print, the difference in printing in Python 3 and Python 2 is, for example, let me just show you, in Python 2 you can just specify it like this, so print hello, and in Python 3 you will need to specify it like this, print hello. You need to specify all of the print statements between the brackets. So let me just delete this since we do not need it. Let us now try to actually scan a website. So let's actually try to scan for one port. So let's try to scan for 135, the website, which is this one. Now you can specify any website you want, and you just basically select it right there. You select the port, and let's see whether that port is closed or open. Now I hope I specified the correct name. Scan results for this IP address. As we can see, it successfully resolved the IP address of this website. Now we can check it out by copying the website and using Nslookup, which is a program that is already pre-installed in Kali Linux, to see whether the IP addresses do match. And as we can see, they do match indeed. So the IP address for this host right here is this one. And also the port that we scanned is actually a closed port. So our program works really well. Basically, this is the only thing we can actually do with the ports. We can scan them, but in the next videos we can actually try to see whether some of those ports will return something back to us. Now sometimes whether, for example, the port is 22, which is SSH, or 21 for the FTP, the software running on those open ports can actually return a banner from the version of those software running. So we can actually see what version of software is running on a certain open port. But in order for us to do that, I will show you in the next video how we can actually install a virtual machine, which is called Metasploitable. We'll use Metasploitable 2 in order to have something to scan and in order to have something to attack in the future videos. So hope you enjoyed this video, and I hope I see you in the next one. Bye! Hello everybody and welcome back, and right now I will show you how you can actually install the Metasploitable, which we will use to actually scan and attack later on. Now it is rather simple to install. All you have to do is go to this website right here, which is information.rapid7. You basically just in your Google search bar you can just type Metasploitable download, and this is one of the first links that will pop up. All you have to do after that is actually specify all of these right here, which is basically first name, last name, and so on. Once you submit that, it will lead you to a page where you can actually download the Metasploitable. Once you click that and download it, I don't think it is that large, perhaps a few megabytes, like 100 or something like that, not really sure. Once you do that, you will receive something like this. So if I just open this, you will receive this zip file right here, so Metasploitable Linux, which is basically the Metasploitable 2. I believe right now there is Metasploitable 3, which is Windows based, but it takes too much hardware in order to run. Basically you need like 4 gigabytes of RAM minimum in order to run that that Metasploitable 3 machine, which is a lot comparing that we are also running the Kali Linux machine at the same time. So we are instead using the Metasploitable 2, which is the Linux machine. Once you actually extract the files, you will have these 5 files right here. The important file right for us is the metasploitable.vmdk, which we will use to actually set up as a disk for our virtual machine. So all you have to do after that, is open up your VirtualBox. So let me close this, and you can actually navigate and make a new virtual machine. Call it whatever you want. I will just call it Metasploitable, and make sure to make it to be Linux, and in the version of Linux go down here and select Other Linux. Now I'm not really sure whether it's 32-bit or 64-bit. Let's just leave it on 32-bit and click on the next. As far as the memory size, 512 megabytes will be more than enough for this machine, so just select next. And right here, instead of actually using the virtual hard disk now or creating the virtual hard disk, we want to use an existing hard disk, which is the hard disk that we downloaded from our Metasploitable. So just go use an existing virtual hard disk, then select right here to select your hard disk, and then try to find it wherever you saved it. As we can see, I saved it on my desktop in new folder. It is this file right here, which is the size of 1.8 gigabytes. You select it right there, click open, select it right here, and you can see right now I have metasploitable.vmdk. So I click here on create, and I am good to go. I created my Metasploitable virtual machine. Right now all you have to do is click here on start, and basically this will start the Metasploitable and it will install it for you. So let's see if this will work, since I had problems with Metasploitable in the past, but I managed to download it before. But as we can see right now, it says unable to boot. Please use a kernel appropriate for your CPU. Now, in case you get this error, just close the virtual machine. So click on X, power off the machine. Go to the settings of the virtual machine. Go under the system and then on the processor, and in the extended features, click on the enable PAE. So click on that, then click on the OK right here, and then try to start the virtual machine once again. Right now, I believe this will fix the error and it will actually start installing the Metasploitable. As we can see right here, it is actually starting up and there is no error, and all you have to do right now is just wait for it to install. It will not prompt you any questions, it will simply install it for you. It is not as complicated as the Kali Linux installation, and as soon as you install it, you will have another virtual machine which you can scan. Now, after the installation of the Metasploitable, what I will show you is how you can actually make both the Metasploitable and your Kali Linux machine to belong to your local area network. Now, by belonging to your local area network, I basically mean to have the IP address which will belong to your local area network. For example, if I go right here, let me just open my command prompt, and on my regular Windows 10 machine I type ipconfig, you can see my IP address is 192.168.1.4. I want my Kali Linux machine to have a similar IP address which will start with the same 192.168.1. something, and also my Metasploitable to be with the same start of the IP address. So let me show you what I mean. First of all, in order for you to log into the Metasploitable, you just need to specify msfadmin as username and msfadmin as password. This will actually open the terminal command line for this machine, where you can execute the same commands that you can execute in the Kali Linux terminal. As we can see, if I type ifconfig in my Metasploitable, you can see that my IP address is actually 10.0.2.15, which doesn't really belong to the range of IP addresses for my local area network. In order to change that, both for your Kali Linux machine and both for your Metasploitable, all you have to do is actually close both of these machines. So I will close my Metasploitable. I will also close my Kali Linux machine. So power off. And all you have to do is go to your VirtualBox, find those two machines. So let me just wait for my Python ethical hacking machine to actually close. while it's closing, we can actually change the settings for the Metasploitable. You click on the machine, go to settings, go to the network settings, and here, instead of attached to net, change that to be bridge adapter. And here you can change the name of your adapter if you want to. I will just leave it by default on this. I will click here OK. I can now start the Metasploitable virtual machine once again, and I will do the same for my Python ethical hacking Kali Linux machine. So I'll go to the settings, I will go to network, from net change it to bridge adapter, and leave it on this. As I said, you can change it if you want to, but make sure to find the one that actually works. Now, one thing also I need to mention is if you're using a wireless adapter, sometimes wireless adapter won't really work in Kali Linux, and they're not supported by Kali Linux, so your best use is to actually use the cable internet connection. Now, you can try the wireless adapter as well. Maybe your wireless adapter is supported, but most likely it will not be. Now you can check what wireless adapters are actually supported by Kali Linux online, and you can actually buy a cheap one for like $10. So that is another option you can do. So once you select all of that, click on the OK, and let us see if Metasploitable booted up. It did. We log in with the msfadmin and msfadmin. And if I just tap ifconfig once again, you can see that right now my IP address is 192.168.1.5. It is no longer 10.0.2.15. And this .1.5 now belongs to my local area network range for my IP addresses. So that would be about it for this tutorial. I hope you enjoyed it, and in the next tutorial we will actually continue coding we will start coding the simple program which will actually retrieve the banner from open ports, whether they actually send the version of software running on them. So hope you enjoyed this tutorial, and I hope I see you in the next one. Bye! Hello everybody and welcome back, and right now let us actually try to code a simple program that will actually retrieve a banner from an open port from the software that is running there. So first of all, you need to open up both Kali Linux and the Metasploitable. As we can see right here, I have them both open. Also, you need to check the previous video if you didn't, in order to make your IP addresses match to the local area network address. As we can see, it belongs right now, since my IP address of my Kali Linux is right now 192.168.1.7, and the IP address of my Metasploitable is 192.168.1.5. So they both do belong to my IP range of local network, and right now we are good to go and actually can try to code the simple banner retriever. So first of all, let me zoom this in so you can see it. We will go to the Python programs and we will go to the scanning. There we will make a program with nano called ret_banner, which basically stands for return banner, and we start with the simple line of hashtag !user bin Python. So right now let's first think of what we need to code. So what we need to code is basically something similar to a port scanner. So we will try for a certain range of ports, for example for first 50 ports, we'll try to actually connect to those ports, and when connecting to those ports we will actually try to receive something from those ports. Now by receive I mean receive some bytes if they send any, and if they do send, those bytes will most likely be something like either prompting us to log in or either sending us the version of software that they are running. So let's see how we can actually do that. All we need to do for now on is import socket library, since with that library we'll be performing all of our actions such as connecting, retrieving data from that port, and so on. So let's make a function called main. As usual, that will be our main function. Now let's first try to actually retrieve a banner from a single port. So let's actually add a port to be 22, which is the port for SSH, which I know that it is by default open on the Metasploitable. Since Metasploitable does have a bunch of ports open, you can use nmap to scan your Metasploitable in order to check it out, but trust me, it is an open port. And right now we can specify the IP address to be the actual IP address of our Metasploitable, which is now 192.168.1.5, I believe. Yeah, it is .1.5. And all we have to do is actually create a variable which will be banner, which will store the result of actual port sending us banner back. So let's see how we can do that. What banner will be? It will be something that we will return from the function return banner, which we didn't code yet, and we will code it right now. But that function will actually take an input of IP address and of the port, which is the port 22. And then simply after that, if banner exists, so if we received anything, we can just print something like this, plus IP, which is the IP of our Metasploitable, plus, whoops, and then we can do something like this, plus banner, so it looks better. What this will do is basically it will print something like this, so plus 192.168.1.5, whoops, then the this sign right here, and then the banner right here will be something like this. At least I believe that is something that it will be printed out. So all we have to do right now is first of all call our function, which is main, and we need to call the return banner function, which we use right here. So this is a non-existent function. We need to make it, and it will be rather simple to make since we will use something similar as to the port scanning function. So banner takes the input of the IP and the port. We place the two dots right here, and we will actually try to connect to that port. So first of all, let's set the default timeout. So socket.set default timeout, oops, to be, for example, 2 seconds. And now we will create a socket object. Let's call it s socket.socket. We don't need to specify anything in the brackets. It doesn't really matter if we specify whether it's IPv4 or TCP protocol. We can leave the brackets closed without anything, and all we want to do right now is to actually connect. So connect to the IP and the port. So use the double brackets, open and close, and select the IP and the port in those brackets. And the banner, which is our variable right here that we selected, will actually be what we receive from that host that we scan. So as.receive, and we want to receive 1024 bytes. So this is a function that we didn't use yet. It basically stands for receiving. Once we connect to the target, this function right here will try to receive 1024 bytes or less from the target, and it will store those 1024 bytes in the banner variable. Now we hope that within those 1024 bytes is the actual banner of the open port software that is running on SSH. So all we have to do after that is return the banner itself, since we specify the banner variable to be this function, which will return then the data to our banner variable. And in case that doesn't work, we will just return from the function itself. So we won't really print anything or do anything, we will just return without saying anything. So let us save this. I hope everything is correct. So yeah, it should be. Right now, we want to chmod the red banner, and if I run it, invalid syntax, okay, so there is some error that we need to fix, such as this one. This error right here needs 2 dots, so let's save it right once again. And as we can see, we successfully were able to retrieve the banner of the SSH port running on the Metasploitable tool. So now, right now we know that on the port 22, the Metasploitable is running SSH-2.0, OpenSSH 4.7 P1 Debian-8 Ubuntu 1. So right now, for example, if we wanted to, we know that this is the banner of the open port, and if you wanted to, you can copy actually this, and you can try to, for example, search on Firefox for any specific vulnerabilities for this particular software. So let's see if there are any. You can just search it like this, so this and then exploit or something like that, it doesn't even matter. Or vulnerabilities, you can search anything you want, and maybe there their software and or that version of the software is currently vulnerable or outdated or something like that. As we can see, OpenSSH security vulnerabilities for the versions 4.7p1, which is our version, as we can see, 4.7.p1. Then you would go to that link and try to actually find some vulnerabilities that you can exploit. But right now, let us actually try to make it scan multiple ports. Whoops. We do not only want to scan the port 22. What we want to actually do is we want to type here for some variable x, for example, in range 1 to 100, let's say. We want to perform all of this. Now the IP address can stay like this, or let's actually prompt the user for an IP address before the loop. So we will just use the same IP equals raw underscore input for the Python 2, or we can actually just use input. So it actually works both for the Python 2 and Python 3. I believe it will. We will see. Enter. Oops. Star, so it looks better. Enter target IP. So once we get prompted that, we enter this loop, which will do all of this for each port in range from 1 to 100. So let's see if we actually retrieve anything. And we can actually strip the new line, or let's see if it even retrieves the new line. Let us just run this program. I'll show you what I meant by that, but let me just run it. Return banner 192.168.1.5. Invalid syntax. So what is now invalid? Let's just go with the raw input. Perhaps that is making a problem, but perhaps not. So let us try. Global name port is not defined. What do you mean global name port is not defined? Oh yeah, we specified here port. So instead of the port, since we use variable here x, we will just delete x and make it port. So for port in range 1 to 100, maybe that is more easy to understand. We want to go to this function for each port number for the same IP address. So change that, Control O to save, Control X to exit, 192.168.1.5. And we can see we actually received something for different ports. We received 4 different banners, which this one I really don't know what this is. But we were able to receive an FTP banner for the port 21, which really isn't specified right here. So this is something that we should add. We want to add which port are we receiving the banner from. So let us do that. And we want to strip the ports from the banners from the new line, so we don't have this open space right here after every port scan. So nano return banner. Let's see how we can do that. We can do that simply. We can remove the new line by doing strip open brackets and then -n. I believe this will do the work. And what else did we want to do? We want to print out the port as well. So we set this, then plus IP, then plus, and we can do plus slash. Let me just do it like this. So plus slash, and then plus port. So if I'm not mistaken, it should work. It should look something like this. 192.168.1.5, port 22. Let's separate it like this, and then something, and then for example open SSH or something like that. So it should look something like that. Let us see if I'm correct. Just clear the screen since this looks really weird. Okay, so we are missing something somewhere. Let us see, what are we? Oh, we are missing a plus right here. So plus port, and then after that we need to specify another plus, and now we should be good to go. 192.168.1.5 cannot concatenate string and integer object. Sounds good, but let's now make our port, since it says that it can't really add an integer to the string, so we need to make our port number to be a string in this case, just in this case where we print it out. In any other cases, for example, this function, it will be an integer, but once we print it out, we need to make it to be a string, so this actually works. So 192.168.1.5, and here we get the same result as before. Not really sure why it is still printing out the new line. Let's see if we can fix that as well. Banner equals s.receive. And then let's try it right here, so strip. But it shouldn't really present any problem. Let us try it once again. I mean, it's not really that big of a thing, but it's still, for some reason, making it with a new line. It doesn't even matter. What matters is that we have an actual program that can successfully scan for the banners of software running on the open port. So that will be about it for this video. In the next video, I will show you how you can create a program which will compare the banners from the scan with the file that contains all the vulnerable software versions. So for example, you download a file from the internet that contains all of the vulnerable software versions, and if our scan retrieves a banner that actually matches some of those banners in the file, we will say that the target is vulnerable. So, hope you enjoyed this video, and I hope I see you in the next one. Bye! Hello everybody, and welcome back, and in this video we will code our vulnerability scanner. So as I said, what we'll be doing is we'll actually perform the same port scanning while retrieving the banners from the open ports. And also, after that, we want to add a function which will check those banners with a text file that contains vulnerable software banners. So I made that file right here, so if you notice, vulnerabilities.txt, if I nano it, what I have right here is a bunch of some gibberish right here. And then at the third position, I have the banner from the SSH port from our Metasploitable, which is the one that we received in the previous video with our return banner program. Then after that, I also have something which doesn't make any sense, just so we have multiple things in the file itself. So right now, let us actually nano the file that we will create, or the program that we will create. Let's call it vulscan.py, and we will start off with the same line as in every program, so user bin Python. And we need to actually import 3 libraries for this program. One of them is the regular socket library, which allows us to actually perform the connection and to receive the data from the target. The other one is the library that we will use in order to check whether the specified file of vulnerable banners exists or not, and whether we actually can execute it or read from it or not. We will use the OS library to do that. This OS library comes with some functions that allow us to check whether the file exists, so that's why we are using it. And the last library is the sys library, which we will use in order to check out the number of arguments specified in the command of the program. Since we will specify the command, or basically what I imagine this program to be, is something like this. So when you run it from your terminal, you will run it like this. So vulscan.py, and after that you want to specify vulnerability banners.txt. So we want the command of the program itself to be vulscan, and then the name of the file from which we want to read the vulnerable banners. So let me just delete this right now, and let's see how we can actually code that. First of all, what we want to do is actually code our main function, so def main, 2 dots. And the first thing we want to check out is to use the sys library in order to check whether we have the correct number of arguments specified in the command itself. So if you count the arguments, The first one is the name of the file, and the second one is the name of the file that we will use from the for the vulnerable banners. So there are, at the total, there are two arguments. As I said, one the name of the program and one the name of the file. So we want to check if length of the number of arguments, so sysargv, equals to 2, which it should equal to 2. We want to have 2 arguments. We want to first of all set the file name, which is the file of our vulnerable banners, to be argument under the number 2. So sys.argv, and then at slot 1. Now, you might be asking once again, why am I saying that it is an argument number 2 and then in the bracket specifying 1? Well, I will remind you that in Python, counting actually starts from 0. So the first argument will be the argument or the name of our program itself, and it will be labeled as 0. Then the second argument will be the file name, and it will be named as 1. Right now, when we said that the file name is argument 2, we want to check whether that file even exists. So maybe the user specified the file name wrongly, and we want to check whether that file exists. So if we will use if not, os.path is a file, so is file, and we need to specify in the brackets file name, since that is the file that we are using. So this basically means if this file doesn't exist, or if this isn't a file, we want to print minus file doesn't exist. Oops, okay, so like this. Then we want to exit the program itself with 0. We also want to check whether the user has permissions to read from that file, so we can do that with this if not os.access. So if we do not have access to the file name, and then os.r_ok, we want to print access denied. Since, for example, maybe the user is trying to run this file as a simple user, and the text file that they want to read from is the root administrator or the root privilege file, and we cannot read from it, so we will just print access denied, and then we will also exit the program itself. So right now, since we checked 2 possible options, we want to add the else statement to this if statement. So we have the if statement. If the length of the arguments is equal to 2, which is correct, then we will check this and proceed to the next part of the code. But if it is not equal to 2, that means that the user specified a different number of arguments, whether that is too little arguments or too much arguments. So we want to print the usage so they know what they need to specify. So usage, whoops, and then we can do it something like this. Wait a second. So usage plus the string of the program name itself. So we can do that with the sys.argv, and then 0, since 0 is the first argument, which is the program name. And then we want to add a plus, so plus the vulnerable file name. So we can do it like this. What this will print is basically the usage, and then the name of the program, and then the name of the file, or basically this part right here, which will let user know that they need to specify a text file with the vulnerable softwares. So after we print the usage, we also want to exit the program. And in any other case, if actually they specified correct command, we want to continue executing the program. So let's see how we imagine this program to work. Well, first of all, what I will do is I will create a list of ports, the most used ports such as SSH port, FTP port, HTTP port, and so on. And we will actually scan multiple hosts and not just one host. So for example, in the previous videos, we were specifying the IP address of Metasploitable. And right now, let's specify for this program to actually scan the entire local host, local network. So how can we do that? Well, first of all, let us make a port list which will contain 22, 21, 22, 25, 80 for the HTTP, 110, 443, You can add as many ports as you like. I will just leave it on here. And right now we want to actually make a loop that will loop through all local machines on our local network. Now, since I don't really want to do all of them right now, I will just scan 2 or 3 machines. So we can do that with 4x in range. And that let's do from 4 to 6, since my IP address of the Windows 10 machine is ending with number 4. The IP address of my Metasploitable is ending with number 5, and that's why we are using from 4 to 6, so we can scan those 2 targets. If you wanted to, for example, scan the entire local network, you would just type from 1 to 255, since that is the maximum number of hosts available on a local network. But right now we will just leave it on 6 and 4, since we are scanning only 2 hosts. And we want to set a variable that so our program can know what the IP address of those hosts are. So we use for x in range, and now we want to set the IP for each loop to be 192.168.1 dot. Then we close the double quotes and add the string of x. Now, why are we doing that? Well, basically, if you have an IP address .192.168.1, we want to loop through this for each x from 1 to 255, so it will look something like this. Then this x right here will actually change value each loop, so we can scan different targets. So that's the idea. Now, after we did that, we want to actually loop through the ports themselves. So for port, in our port list, which is this right here, we want to actually run the same function as in the previous program, which is the return banner function. So let's just do that. So for port, in port list, banner will equal to return banner, with the IP and port as the arguments for that function. And now we check if banner was received. So if banner was received from that certain port, we want to print print plus the IP plus the want to print the slash, so we can separate the slash and the port, or pardon me, the IP and the port. So we want to type the string from the port. So remember that you cannot print an integer, so that's why we use the string from the port number. And then we want to add the banner. Or first of all, we want to add the 2 dots, so we can separate the port and the banner themselves. And now we add the banner then. And right now, we also need to make a function that will actually check whether this banner is in the vulnerable banners in our txt file. So we will do that with function check vulns, which will take an input of the banner and the input of our file name. So the name of the file that we will specify in our command. And these two, which is the red banner and check vulns, we will code in the next video. So for now, we coded a good part of the code. We have our main function right here, which we should actually call down here. And in the next video, we will code the rest of these functions. So hope you enjoyed this video, and I hope I see you in the next one. Bye.